Engineered wood, also called composite wood, man-made wood, or manufactured board, includes a range of derivative wood products which are manufactured by binding or fixing the strands, particles, fibers, or veneers or boards of wood, together with adhesives, or other methods of fixation to form composite materials. These products are engineered to precise design specifications which are tested to meet national or international standards. Engineered wood products are used in a variety of applications, from home construction to commercial buildings to industrial products. The products can be used for joists and beams that replace steel in many building projects. Typically, engineered wood products are made from the same hardwoods and softwoods used to manufacture lumber. Sawmill scraps and other wood wastes can be used for engineered wood composed of wood particles or fibers, but whole logs are usually used for veneers, such as plywood, MDF or particle board. Some engineered wood products, like oriented strand board, can use trees from the poplar family, a common but non-structural species. Alternatively, it is also possible to manufacture similar engineered bamboo from bamboo, and similar engineered cellulosic products from other lignin-containing materials such as rice straw, wheat straw, rice straw, hemp stalks, kenaf stalks, or sugar cane residue, in which case they contain no actual wood but rather vegetable fibers. Flat-pack furniture is typically made out of man-made wood due to its low manufacturing costs and its low weight, making it easy to transport. Types of products. Plywood wood structural panel is sometimes called the original engineered wood product. Plywood is manufactured from sheets of cross-laminated veneer and bonded under heat and pressure with durable, moisture-resistant adhesives. By alternating the grain direction of the veneers from layer to layer or cross-orienting, panel strength and stiffness in both directions are maximized. Other structural wood panels include oriented strand board and structural composite panels. Medium-density fiberboard is made by breaking down hardwood or softwood residuals into wood fibers, combining it with wax and a resin binder, and forming panels by applying high temperature and pressure. Oriented strand board is a wood structural panel manufactured from rectangular-shaped strands of wood that are oriented lengthwise and then arranged in layers, laid up into mats, and bonded together with moisture-resistant, heat-cured adhesives. The individual layers are cross-oriented to provide strength and stiffness to the panel. Produced in huge, continuous mats, OSB is a solid panel product of consistent quality with no laps, gaps or voids. Glued laminated timber is composed of several layers of dimensional timber glued together with moisture-resistant adhesives, creating a large, strong, structural member that can be used as vertical columns or horizontal beams. Glued alarm can also be produced in curved shapes, offering extensive design flexibility. Laminated veneer lumber is produced by bonding thinned wood veneers together in a large billet. The grain of all veneers in the LVL billet is parallel to the long direction. The resulting product features enhanced mechanical properties and dimensional stability that offer a broader range in product width, depth and length than conventional lumber. LVL is a member of the structural composite lumber family of engineered wood products that are commonly used in the same structural applications as conventional sawn lumber and timber, including rafters, headers, beams, joists, rimboards, studs and columns. Cross-laminated timber is a versatile multi-layered panel made of lumber. Each layer of boards is placed crosswise to adjacent layers for increased rigidity and strength. CLT can be used for long spans and all assemblies, e.g., floors, walls or roofs. CLT has the advantage of faster construction times as the panels are manufactured and finished off-site and supplied ready to fit and screw together. As a flat-pack assembly project, Parallel strand lumber consists of long veneer strands laid in parallel formation and bonded together with an adhesive to form the finished, structural section. A strong, consistent material. It has a high load-carrying ability and is resistant to seasoning stresses, so it is well suited for use as beams and columns for post and beam construction, and for beams, headers, and lintels for light framing construction. PSL is a member of the structural composite lumber family of engineered wood products. Laminated strand lumber and oriented strand lumber are manufactured from flaked wood strands that have a high length to thickness ratio. Combined with an adhesive, the strands are oriented and formed into a large matter billet and pressed. LSL and OSL offer good fastener holding strength and mechanical connector performance and are commonly used in a variety of applications, such as beams, headers, studs, rim boards, and millwork components. These products are members of the structural composite lumber family of engineered wood products. LSL is manufactured from relatively short strands, typically about 1 foot long, compared to the 2 foot to 8 foot long strands used in PSL. Finger-jointed lumber is made up of short pieces of wood combined to form longer lengths and is used in door jambs, moldings and studs. It is also produced in long lengths and wide dimensions for floors. I-joists and wood I-beams are I-shaped structural members designed for use in floor and roof construction. An I-joist consists of top and bottom flanges of various widths united with webs of various depths. The flanges resist common bending stresses, and the web provides shear performance. I-joists are designed to carry heavy loads over long distances while using less lumber than a dimensional solid wood joist of a size necessary to do the same task. As of 2005, approximately half of all wood-lined framed floors were framed using I-joists. Roof trusses and floor trusses are structural frames relying on a triangular arrangement of webs and cords to transfer loads to reaction points. For a given load, long wood trusses built from smaller pieces of lumber require less raw material and make it easier for AC contractors, plumbers, and electricians to do the work, compared to the long 2x10s and 2x12s traditionally used as rafters and floor joists. Engineered wood products are used in a variety of ways, often in applications similar to solid wood products. Engineered wood products may be preferred over solid wood in some applications due to certain comparative advantages. Engineered wood offers real structural advantages for home construction. The insulation and air sealing that are unnecessarily part of a major home remodel, addition, or energy upgrade will make a home more comfortable and efficient. Because engineered wood is man-made, it can be designed to meet application-specific performance requirements. Engineered wood products are versatile and available in a wide variety of thicknesses, sizes, grades, and exposure durability classifications, making the products ideal for use in unlimited construction, industrial and home project application. Engineered wood products are designed and manufactured to maximize the natural strength and stiffness characteristics of wood. The products are very stable and some offer greater structural strength than typical wood building materials. 8-story Stadthouse, an apartment complex in London, England, was made with cross-laminated timber panels and is the tallest habitable timber building in the world. Glued laminated timber has greater strength and stiffness than comparable dimensional lumber and pound for pound is stronger than steel. Glued alarm products are also a better environmental choice than steel because they have less embodied energy. Some engineered wood products offer more design options without sacrificing structural requirements. Engineered wood panels are easier to work with using ordinary tools and basic skills. They can be cut, drilled, routed, jointed, glued, and fastened. Plywood can be bent to form curved surfaces without loss of strength. and large panel size speeds construction by reducing the number of pieces to be handled and installed. Engineered wood products provide the natural warmth and beauty of wood. Many products are available in a variety of surface textures and treatments for nearly every aesthetic taste, from rustic to elegant. The products can be easily and beautifully finished with paints, stains, and varnishes. Engineered wood products make more efficient use of wood. They can be made from small pieces of wood that has defects or underutilized species. Wooden trusses are competitive in many roof and floor applications, and the high strength-to-weight ratios permit long spans, offering flexibility in floor layouts. Sustainable design advocates recommend using engineered wood, which can be produced from relatively small trees, rather than large pieces of solid dimensional lumber, which requires cutting a large tree. Engineered wood products also have some disadvantages. Some products may burn more quickly than solid lumber. They require more primary energy for their manufacture than solid lumber. The adhesives used in some products may be toxic. A concern with some resins is the release of formaldehyde in the finished product, often seen with urea-formaldehyde bonded products. Cutting and otherwise working with some products can expose workers to toxic compounds. Some engineered wood products, such as those specified for interior use, may be weaker and more prone to humidity-induced warping than equivalent solid woods. Most particle and fiber-based boards are not appropriate for outdoor use because they readily soak up water. Plywood and OSB typically have a density of 35 to 40 pounds per cubic foot. For example, 3/8 plywood sheathing or OSB sheathing typically has a weight of 1.0 to 1.2 pounds per square foot. Engineered wood flooring manufacturing. Lamella. The lamella is the face layer of the wood that is visible when installed. Typically, it is a sawn piece of timber. The timber can be cut in 3 different styles: flat sawn, quarter sawn, and rift sawn. Keep in mind that each cut will give the board a different final appearance. Core substrate wood ply construction uses multiple thin plies of wood adhered together. The wood grain of each ply runs perpendicular to the ply below it. Stability is attained from using thin layers of wood that have little to no reaction to climatic change. The wood is further stabilized due to equal pressure being exerted lengthwise and widthwise from the plies running perpendicular to each other. Finger core construction. Finger core engineered wood floors are made of small pieces of milled timber that run perpendicular to the top layer of wood. They can be 2-ply or 3-ply, depending on their intended use. If it is 3-ply, the third ply is often plywood that runs parallel to the lamella. Stability is gained through the grains running perpendicular to each other, and the expansion and contraction of wood is reduced and relegated to the middle ply, stopping the floor from gapping or cupping. Fiberboard. The core is made up of medium or high-density fiberboard. Floors with a fiberboard core are hygroscopic and must never be exposed to large amounts of water or very high humidity. The expansion caused from absorbing water combined with the density of the fiberboard will cause it to lose its form. Fiberboard is less expensive than timber and can emit higher levels of harmful gases due to its relatively high adhesive content. An engineered flooring construction which is popular in parts of Europe is the hardwood lamella, softwood core laid perpendicular to the lamella, and a final backing layer of the same noble wood used for the lamella. Other noble hardwoods are sometimes used for the back layer but must be compatible. This is thought by many to be the most stable of engineered floors. Aesthetics. Engineered wood flooring is mainly industrially fabricated in the form of straight-edged boards, with milled jointing profiles to provide for interconnecting of the boards. Such manufacturing is most cost-efficient but leaves an industrial-looking surface. In nature no straight lines exist, therefore there is a rising trend to modify the visual appearance to imitate it. In recent years numerous producers have been taking on the challenge of adding more natural aesthetics. For instance, some manufacturers have come up with an idea to use, instead of straight-edged boards, unedged planks with wood trunk curvature. This method, although providing a natural-looking design, has the disadvantage of requiring a large amount of raw material. The lamellas, which form, are scanned by computer and fitted together to match the forms of the following unedged lamella. This method, although providing a natural-looking design and using quite efficiently the raw material, makes this kind of flooring very expensive and unaffordable to the general public. A method, developed and protected as intellectual property by engineered flooring producer S. is milling the raw material in predefined amount of predefined forms inspired by nature to form a system. The predefined forms are chosen so as to fit together with adjacent boards and adjacent systems, to provide for infinitely extendable surface, covering composing of non-straight-edged boards. This method provides unique nature-inspired aesthetics while being industrially manufacturable with moderate costs to the consumer. Adhesives. The types of adhesives used in engineered wood include urea-formaldehyde resins, most common, cheapest, and not waterproof; phenol-formaldehyde resins, yellow, brown, and commonly used for exterior exposure products; melamine formaldehyde resins, white, heat and water resistant, and often used in exposed surfaces in more costly designs; methylene diphenyl diisocyanate of polyurethane resins, expensive, generally waterproof, and does not contain formaldehyde. A more inclusive term is structural composites. For example, fiber cement siding is made of cement and wood fiber, while cement board is a low-density cement panel, often with added resin, faced with fiberglass mesh. Other fixations. Some engineered products such as CLT cross-laminated timber can be assembled without the use of adhesives using mechanical fixing. These can range from profiled interlocking jointed boards, proprietary metal fixings, nails or timber dowels. Standards. The following standards are related to engineered wood products. N300 oriented strand boards. Definitions, classification and specifications. N309 particle boards. Definition and classification. N338 structural timber strength classes. N386 glued laminated timber performance requirements and minimum production requirements. N313 to 1 plywood classification and terminology. Part 1 classification. N313 to 2 plywood classification and terminology. Part 2 terminology. N314 to 1 plywood bonding quality. Part 1 test methods. N314 to 2 plywood bonding quality. Part 2 requirements. N315 plywood tolerances for dimensions. N387 glued laminated timber large finger joints performance requirements and minimum production requirements. N390 glued laminated timber sizes permissible deviations. N391 glued laminated timber shear test of glue lines. lines. N392 glued laminated timber, shear test of glue lines. N408 timber structures, structural timber and glued laminated timber, determination of some physical and mechanical properties. N622 1 fiberboards, specifications, Part 1, general requirements. N622 2 fiberboards, specifications, Part 2, requirements for hardboards. N622 3 fiberboards, specifications, Part 3, requirements for medium boards. N622 4 fiberboards, specifications, Part 4, requirements for soft boards. N622 5 fiberboards, specifications, Part 5, requirements for dry process boards. N1193 timber structures, structural timber and glued laminated timber, determination of shear strength and mechanical properties perpendicular to the grain. N1194 timber structures, glued laminated timber, strength classes and determination of characteristic values. N the 1st of January 1995 Eurocode 5, design of timber structures, Part 1 to 1, general common rules and rules for buildings. N12369-1 wood-based panels, characteristic values for structural design. Part 1, OSB, particle boards and fiber boards. N12369-2 wood-based panels, characteristic values for structural design. Part 2, plywood. N12369-3 wood-based panels, characteristic values for structural design. Part 3, solid wood panels. N14080 timber structures, glued laminated timber, requirements. N14081-1 timber structures, strength graded structural timber with rectangular cross-section. Part 1, general requirements.